This video explains the example for shrink and shrinkage. A suspended slab which is externally unrestrained is to be built in Melbourne. Its top and bottom surface are exposed. So this top and bottom surface are exposed to an interior environment. Estimate the final stresses in the steel and concrete due to the shrinkage at 30 years, and also need to check whether it's cracking or not. We have given some constant value for stress. Sigma 0 is 0.3 fcds, and characteristic compressive strength fcds is given 32 megapascals. It's given 130 millimeters, and it has a top and bottom reinforcement here, which is not shown here. Later I will show it this one on the figures. And it has a N12 300 at a distance of center to center 300 at top and bottom of this one. Now to solve these problems, we have several steps to follow. Now we take the first assumption saying that 1 meter wide strip. So for example, this concrete has a 1000 millimeter wide strip. That's the assumptions that we make it at the start. Now let's talk about the shrinkage strain first. Now to calculate the design shrinkage strains, we need to follow 3 steps. First, we calculate the chemical or autogenous shrinkage strains. Second, we calculate the drying shrinkage strains, and then finally we calculate the design shrinkage strain. Now let's talk about the chemical shrinkage strains first. Now to calculate the autogenous shrinkage strain or chemical shrinkage strains, we have an equation of epsilon CAC, and that follows here, that is written here. Now this equation is given on the clause 3.1.7.2, that is given here 3.7.2 on the clause number 46, and that equation is given here, autogenous shrinkage strain, which is 3.1.7.22. that's copied here. Now in that case, we need to calculate this epsilon CAC stars. Now this equation is also given on the same page. So if you scroll it down a little bit down here, we have 2 equations given to calculate epsilon CAC stars for the FCDS less than 50 megapascal and FCDS greater than 50 megapascals. Now we have given FCDS 32 megapascals, that is given in the questions, 32 megapascals. In that case, we are forcing to use these first equations, which is less than 50 megapascals. So we are using this 0.07 so on equation, that is I copied here. Once you have these equations taken from Australian standards, we can substitute the FCDS value 32 megapascals, that is given in the questions, 32 megapascals minus 0.05 times 50 times 10 to the minus 6. Multiplication give 8.7 10 to the power 5. Generally strains should have 10 to the power negative minus 6, so we are converting this one by dividing 10, so you have 87 times 10 to the minus 6. Now once you calculate these values, we can go back to here, shrinkage strains, that is given in the clause 3.1.7.2, that is equations here. We substitute this 87 times 10 to the minus 6 that we just calculated, star value 1 minus 0.07t. Now this t is the number of days. Now we have given 30 years in the questions. It says that we will have a concrete due to the shrinkage at 30 years. So we need to convert these 30 years into days. So to convert 30 years into days, we multiply by 365, that give us 10,950 days, that we substitute here 10,950 days. Now please note here, when the t is very large value, that become infinity, and then if you multiply infinity with some number, that become negative infinity, and if you take e to the power negative infinity, that becomes 0. So 1 minus 0 is 1, so that for 1 times 87 times 10 to the power 6 gives 87 times 10 to the power 6, or you can use the calculator here, still it give you the same value. So 87 times 10 to the power minus 6 times 1 minus, let's say that is the e to the minus 0.07 times 10,950, that's give us 8.7 times 10 to the minus 5, that is 87 times 10 to the minus 6. Now we calculate this first step, which is the chemical shrinkage or autogenous shrinkage strain. Now the second step, we are calculating drying shrinkage strain. Now to calculate the drying shrinkage strains, we have an equation to calculate the drying shrinkage strain that is given in the Australian standards. On the same page, on page number 46, we have a drying shrinkage strain which is K1 ESD, K1 K4 epsilon CSDB. So that is given here. Now in that case, we can have we need to calculate this basic drying shrinkage strain, which is epsilon ESDB. Now that equation is given here on the Australian standard. So if you go back here, you can see that basic drying shrinkage on the same page, on page number 46, we have a same drying shrinkage strain, basic drying shrinkage strains given in this one, that copied here. Now in here we need to get this epsilon CSD B stars, which is 800 times 10 to the minus 6. So that is, if you go to the page number 46 again, you have just down below we have this value given 800 times 10 to the minus 6. So that is adopted here. Once you have this value, you can substitute that value here. FC dash is 32 given in the questions. FC dash is 32 given in the questions. Times 800 times 10 to the minus 6 give us 5.92 10 to the minus 4, and then we convert this one by dividing 100, so that is given 592 times 10 raised to minus 6. Now once you have this ESB dash value, now we need to calculate K1 and K4. K4 is 0.64 for an interior environment. In the questions it says that it's an interior environment. Its top and bottom surface are exposed to an interior environment, so please take a note. Now hypothetical thickness TH is given on page number 27 of AS3600. On page number 27, just down below we have a TH value, hypothetical thickness of the member used to determining creep and shrinkage, and taken as 2Ag divided by UE. So that is written here. Now where Ag is the gross area, that is defined on page number 17. Ag is a gross cross section area of a member, and UE is exposed parameter, that is given on page number 28. On page number 28, on the first line it says that exposed parameter of member cross section plus half the parameter of any closed void constraint, therefore used to calculate TH. Now gross area is 1000 times 150, that is taken from here. We have a gross cross section area, we assume 1000 millimeter strip times by 150, that is the cross section area, and then exposed parameters at these exposed parameters is calculated. And now in the question it says that that top and bottom surface are exposed to an interior environment. So top and bottom surface are exposed, and top surface is 1000, bottom surface is 1000, so 1000 plus 1000, 2000. So it is 2 times 1000 is 2000, that is give us 150 millimeters, that is TH. Now to calculate the K1, we have two approaches. Either we can use the figure 3.1.7.2. Now we can use on the page number 47, we can use figure 3.1.7.2, or we can use these equations. Okay, let's do it with the equation first. Now we need to calculate K1 and alpha 1 value. Now K1 I copied here, the K1 value I copied here from here. So alpha 1 T 0.8 T 0.8 plus 0.15 TH. Now alpha 1 we need to calculate first, so that is alpha 1 is taken from here, 0.8 plus 1.2 E minus 0.05 TH, and then you substitute this value. TH we calculated 150, and that is taken from figure 3.1.7.2. Once you calculate alpha 1 1.37, you substitute 1.37 here. We calculate the number of days, which is 10,950. In the questions is given 30 years, and then we need to convert that 30 years into days. That 30 times 360 over is give us 10,950 days. So that is time is 10,950 power 0.8, 10,950 0.8 plus 0.15 times 150 give us 135. Now we can confirm this value using this one. Now TH is 150, so it should be between this 100 and 200, so, and that is 30 years, so it's in the middle. And if you draw the line across, we will get 1.35 around here, 1.35 for the given value of TH somewhere here in the middle, and that's for 30 years. So that is match with that calculated value. Now, so drying shrinkage, we can calculate K1, K4, epsilon CS dB. K1 we calculated 1.35, we just calculated. K4 we get it 0.65, and we get epsilon CS dB that we calculated 592. That is 592 times 10 to the minus 6. And then if you simplify that one, give you 5.19 times 10 to the minus 4, and we convert this one by dividing 100, so that is 519.48 times 10 to the minus 6. Once you calculate the drying shrinkage, as you know, we have 3 steps. Once we calculate the drying shrinkage, we need to calculate the design shrinkage. Now that design shrinkage that we can calculate. Now design shrinkage strain is epsilon CS equal to epsilon CSA plus epsilon CSD. Now that equations that we taken from, that is on the clause 3.1.7.2, that is the equation here on page number 46. And epsilon CSB we calculate 87 times 10 to the minus 6 in the previous step. Epsilon CSB on the first we calculate a chemical or autogenous shrinkage strain, 87 times 10 to the power 6. And then we calculate the drying shrinkage, which is 519.48. This 519.48 10 to the minus 6. That addition will give you the design shrinkage strain 604.48 times 10 to the minus 6. Now in the next video we will look at the creep. Thank you.